Welcome to Further Maths Class Great Champions. In this class, I will be teaching you another application of differentiation, which is the turning points or maximum and minimum points of a function. So what are maximum and minimum points of a function? The maximum point of any function is the highest value of the function that it can give as output for any possible input, while the minimum value of a function is the least value the function can give as output for any possible input. Let us consider a graphed function as shown on the screen. This function or this curve will have local maximum and minimum points. To determine the exact value of the local maximum and minimum point will require the use of or application of differentiation. So in this class, I'll be teaching you how to determine the local maximum or minimum turning points of a function. But it is, however, worthy of note that it is not all functions that have maximum and minimum points. Some functions do not possess maximum and minimum points. Let us consider a function of f of x equal to x cubed. This function do not have maximum and minimum points. It is an increasing function. It is an increasing function as it moves from the left or the negative axis to the positive axis, and so it does not have a maximum and minimum points. There are also some functions that have absolute value of maximum and minimum points. That is, they do not exceed that value. An example of such a function that exhibits absolute maximum and minimum value is a sine curve or a sine wave. As you can see, the sine wave has an absolute value or a highest point beyond which it cannot exceed. And so if you draw a straight line through the turning points of this sine curve or sine wave, the absolute value in the positive, the maximum point is 1, while the minimum turning point is -1, and so it cannot exceed these two values. Before we take calculations involving maximum and minimum points of a function, it is worthy of note that at maximum and minimum points in a curve, dy all over dx is equal to 0. That is, if we differentiate the function at that point, it will always be equal to 0. At maximum points in the curve, if you take the second derivative of that function, it is always less than 0 or it is negative. And if at minimum points of a function or at minimum point of a curve, if you take the second derivative of the function at that particular point, it is always greater than 0 or it is always positive. We are going to use this when I start teaching you calculations involving maximum and minimum points. Let us take this particular question. Find the turning points of the function y is equal to 2x cubed minus 6x squared minus 18x plus 3. So the first thing you do if you want to take the turning points of a function is for you to differentiate the function with respect to x and equate it to 0. And so you are going to differentiate the function y with respect to x. So you differentiate each term. When you differentiate 2x raised to the power 3, you are going to have 6x squared. And when you differentiate minus 6x squared, you are going to have minus 12x. If you differentiate minus 18x, it will give you 18. And of course, if you differentiate the constant plus 3, it will give you 0. So the expression will turn into a quadratic equation, which is 6x squared minus 12x minus 18 equal to 0. If you factorize this quadratic equation, you have x minus 3 bracket x plus 1 equal to 0. And if you solve completely the expression, you are going to have x is equal to 3 or x is equal to minus 1. These are the critical points of the function, and so you need to determine the value of y at that particular point to be able to know the turning point of the function. And so what we do is that we substitute the value of x back into the original function. So when we pick the first solution and we substitute the value of 3 into the original function, which is 2x raised to the power 3 minus 6x squared minus 18x plus 3, you are going to have 2 bracket 3 raised to the power 3, and then you have minus 6x squared minus 18x bracket 3 plus 3. And so you evaluate the expression further to determine the value of y by expansion. And so when you expand the expression 3 raised to the power 3, you are going to have 27. And so 27 times 2, you have 54. Similarly, you expand other terms in the expression and you are going to have 54 minus 54 minus 54 plus 3. And so when you evaluate these, the value of y will be equal to minus 51. This implies that the coordinates of the turning point is 3 and minus 51 at x equal to 3. And so similarly, we also determine the turning point as x equal to minus 1, which is the other solution, the other critical value. In the same manner, we substitute minus 1 into the expression to determine the corresponding value of y. So at x equal to minus 1, you are going to have 2 brackets minus 1 raised to the power 3 minus 6 bracket minus 1 raised to the power 2 minus 18 bracket minus 1 plus 3. And by expansion, if you expand this expression, you have minus 6, rather minus 2 minus 6 plus 18 plus 3. And if you solve this completely, you are going to have the answer y equal to 13. Therefore, the coordinate of the point of the turning point at x equal to minus 1 will be minus 1 bracket 13, which is the value of x and y at that point. Hence, the turning point of the function 2x raised to the power 3 minus 6x minus 18x plus 3 will occur at minus 1, 13 and 3 bracket minus 51, which is the value of x and y coordinates at those points. I will teach you another example. A curve is defined by f of x equal to x raised to the power 3 minus 6x squared minus 15x minus 1. You are told to find the maximum and the minimum points of this function. To determine the maximum point and minimum point of this function, as I taught you in the first example, you differentiate the function with respect to x and equate it to 0. And so when you differentiate 3x raised to the power 3, you are going to have 3x squared. And when you differentiate minus 6x, you have minus 12x. And when you differentiate minus 15x, you have minus 15. Of course, when you differentiate a constant minus 1, you are going to have 0. So you are going to have the quadratic equation 3x squared minus 12x minus 15 equal to 0. When you divide through by the common factor 3, you are going to have x squared minus 4x minus 5 equal to 0, just to simplify the expression. And then you factorize this quadratic equation. when you factorize this quadratic equation, you are going to have two factors, which is x minus 5 and x plus 1. And so at this point, we do not know which of the critical values that will give the maximum point of the function and which one will give the minimum point of the function. And so we are in such a case like this, you carry out a second derivative test for the function to be able to determine this. And so you differentiate the original function 2 times, you differentiate it again, and when you do this, the second derivative of the function will be equal to 6x minus 12. That is, you differentiate the function twice, the original function twice. And after differentiating the original function twice, you subsequently substitute the critical values into the function. When you substitute the critical values, which is x plus 5 and x minus 1, into the second derivative of the function, when you have a positive value, that will be the minimum point, and when you have a negative value, that will be the maximum point of the function. And when you determine this, you will subsequently find the coordinate of x and y at that point. And so when we substitute the first critical value, which is when we differentiate, substitute x equal to 5 into the second derivative of the function, you have 30 minus 12, which is equal to, that is, you have 6 bracket 5 minus 12. When you evaluate this expression after substituting x equal to 5 in the expression, you are going to have 30 minus 12. And of course, you know that when you subtract 12 from 30, you are going to have 18 as the value of the second derivative, which is a positive answer. Since the second derivative after substituting the critical value gave you a positive solution, that means it is at a minimum point at this function, at this particular point, which is the second derivative is greater than 0. So it is the value of x is at a minimum point at this function. So after determining the max, that it is a minimum point, you subsequently substitute the value of x back into the original expression to determine the corresponding value of y. And when you do this, when you substitute the value of x to get the coordinates at the minimum point, you substitute the value of x, which is the critical value, back into the original function. And so you are going to have 5 raised to the power 3 minus 6 bracket 5 raised to the power 2 minus 15 bracket 5 minus 1. And when you evaluate this, you are going to have the value of y being equal to minus 101. Therefore, the minimum point of the function occurs at x equal to 5 and y equal to minus 101. So this is the minimum point of the function. You subsequently substitute the second critical value of the function, which is x minus 1, back into the second derivative to determine if it will give a maximum point at that function, the nature of the point to give at that function. And when you substitute minus 1 into the function, the second derivative of the function, you are going to have minus 18 as the answer. This implies that since the second derivative of the function gave a negative answer, this implies that this square y all over dx, which is the second derivative of function, since it's less than 0, it implies that x is at a maximum point at this value. So that means we are going to determine the maximum point of the function. So having confirmed that x is at a maximum, you subsequently substitute the value of x back into the original function to determine the coordinates or the corresponding value of y. And so when you substitute the value of x, which is x minus 1, back into the original function, you have minus 1 raised to the power 3 minus 6 bracket minus 1 raised to power 2 minus 15 bracket minus 1 and minus 1. Evaluating this by expansion, minus 1 times minus 1 times minus 1 will give you minus 1. While if you multiply minus 1 by minus 1, you're going to have plus 1. And when you multiply this by minus 6, you have minus 6. And you have plus 15 minus 1. And when you evaluate this, you have y is equal to 7. So that means at x equal to minus 1, which is at a maximum point, the corresponding value of y is equal to 7. So the maximum point, the coordinates of the maximum point is minus 1, 7. So we have determined the maximum and the minimum point of this function. That means the maximum and the minimum points of the curve respectively will be 5 bracket minus 1, which is the minimum point, while the maximum point will be x minus 1 and y is equal to 7, or the coordinates will be minus 1, 7. Thanks for watching this video and joining the class. Do remember to attempt all the quizzes and assignments in the portal and clear all your restrictions. I hope to see you in my next class. Bye for now.